Hi, welcome everybody. Thanks for joining. We're starting on time. So before I move on to introduce you to our speaker today, please feel free to use the chat function in the right of your screen to submit your questions, and we will try to answer if time allows us, of course. So let me introduce you to Asaf Fadida from WAF. And Asaf, if you please, before we move on to our questions, please give our audience a brief description of your role in the company.
Of course, yeah. So, hi everyone, good morning again. So, as Mariana described, my name is Asaf Fadida. I've been a while in the cybersecurity area. I've developed a variety of security solutions from endpoint security to cloud security, XDR solutions, and right now, me and my fellows at WIB, we're focusing on the new era of API security. My job at WIB, I'm a director of engineering and basically a developer, passionate about cloud native technologies, and would be happy to answer your questions today.
Excellent. Thank you, Asaf. So the first question, I wanted to ask, what is the difference between WAFs and API security?
Okay, so this is a question that we hear a lot because a lot of people don't really understand if they already have a WAF that protects their application, why do they need any API security solution? So first, let's take a step back and talk about the intention of both tools and what each of them were designed to do. So WAF basically designed to protect web applications in a rule-based mechanism. So the way that WAF works is WAF will look for a specific list of potential structural security issues, such as SQL injection, XSS, requests from IPs from unfriendly countries or unfriendly actors and so on. And when a WAF will see this kind of a malicious request or any kind of malicious properties within this request, it will block the request and it will protect the server from the malicious traffic. Now, on the other hand, API security is all about finding security issues and misconfiguration inside your business logic of your application. So every product in every company in the entire globe has its own business logic. One company will work with logistics, other company will work on the healthcare area, other one financials, and every logic between every product is totally different. So it's really hard to write this kind of static rules that WAF has in it in order to protect application from business logic issues. Now, let's understand why are we even looking to solve this problem? I mean, where this problem was when WAF first introduced to the world, and why haven't we dealt with this issue even before? So in the past few years, there was a huge digital transformation around the world on a lot of organizations. And this digital transformation created a lot of interfaces between application consumers and application providers. Now, until that point, we always wanted to keep people out of our organization, but these digital transformations made us to want to open our logic, to open our application, so other consumers will be able to use it. So now we are creating very efficient and easy to use interface using API to let people in, but we need to remember that on the same efficiency, attacker can use the same interface. So in the one hand, we don't want to block the interface because we want the digital transformation to work, but we also want to manage the risk and control this interface. So we talk about how each solution is implemented and what it's doing, but let's talk about the differences of the two solutions from risk perspective. So WAF designed to secure the risk from known and basic attack vectors, mostly for web applications. while API security solution designed to secure risk from a bug in your application business logic. So you can continue using WAF in order to protect your application server, but it means that you are managing the risk only on the vector of known and basic attacks. If you want to manage the risk of potential business logic issues in your application, and you continue to use a WAF, then your only barrier is that you are counting on your developers to make no mistakes. And I hope we all understand that that's not a good risk management. So it's something that we should take care of, and this is more or less the main differences between WAF and API security solutions.
Very well. Thank you, Asaf. Very interesting.
Sure.
So can API security replace WAFs completely?
Okay, that's another interesting question. So first of all, it depends. It depends because API security solution and WAF, they're both two pieces of code that are intended to manage two different risks, as we discussed before. You can take the two pieces of code and put them on the same box, and then you have a WAF with API security solution or API security solution with WAF. But these days, when new companies are trying to create their own API security solutions, they're focusing on the API risk and not on the WAF risk that already out there. And there are a lot of companies that have answer for this kind of risk. So it really depends. But right now, there is no like a real WAF that also contains all the API security issues answers.
Okay, very well. Asaf, have you witnessed an incident where a customer had a WAF that didn't protect against attacks?
Yeah. So I'll give a short example from the past month. Engagement that we have with a very big company here in the US. The company exposes 100 of different API endpoints. And we have found some routes that are exposed to BOLA, Broken Object Level Authorization attack. I'll describe in a second what this attack means and why WAF can't find this kind of attacks. So the anatomy of a generic, let's take, for example, update API. Most of the time, the update API method will be used by put or post. And the logic will be something like, we will ask from the server to update some resource. The server will verify that the current user has access to the resource, and then you will run the update on that specific resource. Now, when you are asking a server to update a resource, you need to provide some kind of reference to the resource, some kind of resource ID, in order to let the server which resource exactly you want him to update. Now, in most of the cases, the ID of the resource will be passed to the server using path params. There are some developers that we see around the globe that prefer to pass the ID using body params, but it's less common. But the real issue beginning when we see the same ID on two different sections of params. We can see it on the path params and in body param, for example, or query params. Now, why is it so annoying and should let us know that something not good is happening right now? Because if we will come back to the anatomy of the API, we start with some validation that the user has access to this specific resource. Now, most of the time when we see duplication of ID in a request, it meaning that there is part of the logic that been done on a specific ID, and the other part of the logic been done with the other ID. So what we found that we can do with this specific customer in the US is we provided on the path param an ID that for a resource that we have access to, but on the body param, we set an ID of a resource that doesn't really belong to our user. So this is exactly how we break the authorization layer or the authorization model of the server by passing two different IDs. Now, this kind of attack WAF can detect because it's very business logic oriented. And it can be detected using static rules like the rules that WAF's working on.
Very well. Very interesting. So now, Asaf, talking about limits. Is API security limited in some ways that WAFs are not?
So yeah, definitely, yeah. And that's mainly by design, because the problem that we're dealing with in the API security area is totally different from the problem that WAF area are dealing with. So the main issue, the main limit that API security solution have that WAF doesn't have is a very high rate of false positives. And let's understand why do we have this kind of issue. Due to the fact that the same solution, the same API security solution, should solve application issues agnostically. And due to the fact that applications all around the globe are different from each other in its business logic, it's very hard to get accurate results, which means we get a lot of false positive. Now, you must understand that false positive in this area is by design. You can't say, I will find a better solution that will reduce the false positive. You just need to find a solution of how to handle the amount of false positives. So there are multiple ways to tackle the issue. One approach, for example, could be understanding from the source code of the application how the logic look like and what the code was intended to do. Another approach could be validating the issue actively, like actively attacking the server with the alerted scenario in order to better understand if it's a real issue or not. Now, there might be another approaches to tackle the false positive issue, but the common of all of them is that a high rate of false positive is an issue by design when dealing with API security, and you just need to handle that correctly. And if you are doing that, then you are on the right direction.
Very well. So how can you understand actual logic and defend against these types of attacks?
That's another excellent question. So in order to answer that question of how can we learn the behavior of API or the behavior of an application, let's break down the way that we can learn about application logic into three different parts. The first tool that we can use in order to understand API logic is to just observe the production environment and see how the production environment look like just by observing it, not doing anything actively. The second approach would be to actively use the application and see how it behaves according to different scenarios. And the third tool that we can use in order to learn about application behavior is to learn its documentation and its source code in order to understand what the application intended to do. And when using all these three tools as an input, you can learn a lot about every application. Now, this is also the place to remind everyone that it's really API security is a solution. It's not about just observing traffic in production environment and we good, because then you get a lot of noise and it's not accurate. And the reason that we're still thinking in this direction is because this is the solution that we are aware of. This is the solution that we know from the WAF world, from the WAF perspective. Because what WAF do, it just get the traffic, looking for some issues inside it, and then we say, okay, let's take the same solution and try to adapt it into API security. It won't work, because API security, it's a new problem that requires new solutions and a new way of thinking. And just for example, by breaking down the API logic into three parts, taking us to a whole different story of educating our SecOps operation, the SecOps teams or the developers of how to implement APIs, and that not even related to production environment. Production environment is one tool in this area of API security.
Very well. So before I go to the next question, just to remind our audience to, if you have, we still have a little time. So if you have any questions for Asaf, you can write them in the chat section. So the next question for you, Asaf, is how can you deal with minimizing the risk of unknown and shadow APIs?
Okay, so let's first understand what's shadows and unknown APIs. So let's take, for example, the first tool that we have talked about before, observing a production environment. Now, let's say you have the best detection tool in the world that have zero rate of false positive. And by just looking on the production environment and inspecting all the traffic, it can tell you which APIs you have, which anomalies you have on all of them. And then you need to ask yourself, is that enough? Because you are securing the APIs that you know that your customers are using, but you have no idea what else you are exposing to the world. And this is where the unknown API and shadow API are coming into the picture. And this is why just looking on production environment is not enough. So the way that you can learn more about which API you are exposing, but no one uses it, but it still exposes you for security issues, is to use the other two tools that we talked about before, actively using the application or actively fuzzing some kind of routes of the application in order to find some APIs that you couldn't see before, just by observing the production environment. And the other tool, which give you a much better solution in order to find all the unknown and shadow APIs, is to scan your own source code in order to see the exact API that you are exposing. Now, if you will take the discoverable APIs that you saw from the source code and the discoverable APIs that you get from the production environment monitoring, and you put them on the same view, on the same table, you can see exactly which APIs are underused, how are they used, and on the same time, you can see which APIs no one uses, but you are still exposing them. You still need to manage the risk on those APIs. You still need to monitor them. So this is how you can detect your unknown and shadow APIs and also add them into your security program under your API security program.
Excellent. So how do you see the API lifecycle automation with API operations?
Okay, so we talked a bit about what's API built of. So of course, API will be deployed on production environment, but the beginning of the API starts with source code. So we have developers writing some code, writing some APIs. They need to deploy them to some kind of a QA or a pre-production environment in order to be tested, and then they're going to production. So instead of just shipping the API to production and hoping that nothing bad will happen, we can start by when the developer will do his first commit, first push to the Git repository or any other source control, we can start by scanning his source code, first of all, to find if there is any new APIs that he has developed and want to push to production. And if there are, what's the risk about them? What's the issues that are they exposing? It might be is the API authenticated? Is the API exposing a BOLA attack? What are PIIs that are exposed within this API? Now, right after this stop on the life cycle, the next stop, as we said, would be a QA environment and pre-production environment. In this spot, you can start to use the API and try to even attack your API, try to simulate some penetration testing on that, on the resource level, on the API level, in order to understand, is this API should go to production, should I ship it or not? And only after you got these two verifications that the API is good enough to go to production, then you start monitoring that in production. Now, the life cycle is not done over there, because even after we ship an API, we can still find some anomalies on the API usage right after we deliver that to production. So let's say we found an anomaly, the anomaly has been verified, and now we are holding an issue that we know that some developer need to remediate, need to fix. So the way that we want to continue the life cycle of the API is to let the developer remediate the issue, let him do the code fix and push the code fix into the source control. Then we will try to retest and revalidate the API on QA pre-production environment, and then automatically the issue will be resolved. And this is the closure of the API lifecycle from development to testing to production. There was an issue, we fixed that, and the issue will be auto-resolved.
Excellent. So we have like 2 more minutes. I don't know if you can quickly give us your insights on how can API security be positioned higher in priority with the business, within the business.
So I think that the first thing we need to remember is these days, the numbers show us that more than 80% of the traffic in the internet, in the wide world web, is APIs. And it's not even APIs from a web browser or application, it's just B2B API interfaces. And just by learning this now, just by hearing these numbers, we need to understand that it's not something that we can put aside, it's not something that we can ignore, and we must address some kind of solution for that new era, for that new attack surface. And new solution, new problem requires new solutions, as we said before.
Absolutely, yeah. Well, I think the time is up. So, Asaf, thank you so much for sharing with us your insights, and for our audience. Thank you so much for participating in this roundtable. And we invite you to visit our sponsor section and other workshops and roundtables that are available for you, and that we will have along the day. So thank you so much, everybody. And well, keep enjoying this event. Asaf, thank you so much.
Thank you, everyone. Have a nice day. Thank you, Mariana.
Thank you.
Bye-bye.
Bye.